Welcome back, folks. We are starting Chapter 6, Section 6 today in Precalculus. So we're going to start off with some basic vocab and solving, and then we'll get into some practice. All right, so jumping right in. So to solve basic trig equations, we're going to use rules from algebra, and some of those options are the property of equality or factoring. We're going to end up using. So the directions are either going to specify one of these three things, and if the directions specify principal roots, that means we are going to use our inverse trig functions: arcsine, arccosine, or arctangent. Okay, we're only going to get one answer. Okay, if the directions specify solutions in the interval 0 to 2 pi or 0 to 360, then all solutions will be on the unit circle. So one rotation of the unit circle. And then if it asks us for all real solutions, that means all solutions. We're going to be making little expressions for our answers. So those are going to have plus 2 pi k, plus pi k, etc. Okay, recalling that the period of a sine, cosine, secant, or cosecant graph was 2 pi, and the period being how long the graph or function takes to repeat itself. Those are going to be the functions that we have plus 2 pi k. And the period of a tangent or cotangent function was pi. So those are going to be the functions that are going to end in plus pi k. Okay, so beautiful. Let's jump right in and get started here. So we're being asked to find the principal root of 2 sine of x minus 1 equals 0. So we can add 1, divide by 2, and we get where is sine of x equal to 1/2. And the principal root means using arcsine. So we'll take the arcsine of 1/2, and what angles have a sine value of 1/2 in quadrants 1 or 4? That's going to be pi 6. Super simple. You're going to want your unit circle for all of these, or most of these. So our next one here, we're just trying to solve, basic rules of algebra. Get all your x's on one side and everything else on the other. So I'm going to add my sine of x over to the left. So I'm going to get 2 sine of x, and then I'm going to move this radical 2 over to the other side, making it a negative radical 2. And then divide by the 2, so I get where does sine of x equal negative radical 2 over 2. And we're being asked for all solutions on 0 to 2 pi. So what answers from 0 to 2 pi, or on one revolution around the unit circle, have a sine value of negative radical 2 over 2? Again, look at your unit circle, or you should have pretty much mastered it by now. You should know that is 5 pi fourths and 7 pi fourths. Okay, super simple right there. So the next one, we're being asked to find all real solutions where cotangent squared of x minus 1 equals 0. So still basic solving. Where is cotangent squared of x equal to 1? Meaning where does cotangent of x equal plus or minus 1? Just taking the square root of each side. Okay, so typically we don't have our cotangent values memorized or much easily recallable, but we can reciprocate that, and if you flip it, you get tangent of x, and if you flip plus or minus 1, you get plus or minus 1. So where is tangent equal to plus or minus 1? It's every single pi fourth on the unit circle. So 3 pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. Super quick there. The next one we're going to try to solve is finding all the solutions on one rotation of the unit circle for 3 tangent squared of 2x minus 1 equals 0. So we're just going to solve, and then we'll address the 2x at the end. Okay, so if I add my 1 and divide by my 3, I get 1/3. And then I square root to get rid of my squared, and I'm going to get tangent of 2x is equal to plus or minus radical 3 over 3. So if you don't understand how we went from here to here, square rooting the top, square root of 1 is 1, square root of 3 on the bottom, we rationalized it and put the radical on top and then removed it on the bottom, and then we have our plus or minus because we square rooted the solve. So basically we're trying to figure out where is tangent of 2x equal to radical positive or negative radical 3 over 3. Well, if we just ignore the 2x for now, we know that our tangent values are equal to positive radical 3 over 3 at pi 6 plus pi k. So in other words, pi 6 plus every period. So the graph is going to repeat itself every pi. Okay, and it's equal to negative radical 3 over 3 at 5 pi 6 plus pi k. Okay, the negative radical 3 over 3 values will repeat every pi. Okay, so as long as 2x is equal to one of those solutions, then the tangent of 2x will equal plus or minus radical 3 over 3. So solving for x, really simple, just divide by 2. You end up with pi 12ths plus pi halves, okay? And for this little expression, you end up with 5 pi 12ths plus pi halves, k. Okay? Now, the k just represents iterations of the period, so don't really worry about the k. It's just you plug in 1, 2, 3, 4, 5, just how many times the period repeats itself for anyone that's confused about the k. But nevertheless, if we're trying to figure out all values from 0 to 2 pi, we just start plugging in values for k. So you plug in 0, you get pi 12ths. Plug in 1, so you're just adding pi halves. And when we add pi halves, it's going to go for the same down here. When we add pi halves, that's the same as adding 6 pi 12ths. So you're going to see how I'm able to do this really fast. If I add 6 pi 12ths, I get 7 pi 12ths. Then I get 13 pi 12ths. Then I get 19 pi 12ths. I'm going to stop right there because if I added another 6, I would get 25 pi 12ths, which is bigger than 2 pi. So now I'm going to go down to this expression, start plugging in values for k, plug in 0, so I get 5 pi 12ths, and then I'm just adding 6 pi 12ths every time I want to add pi halves. So what's that? 11 pi 12ths, 17 pi 12ths, 23 pi 12ths, and the next one will be 29 pi 12ths, which is bigger than 2 pi. So there's all my answers. Okay. Now if you go back and think about it, you're like, okay, well, how many different values is tangent equal to plus or minus radical 3 over 3 on the unit circle? Well, that's 4. Well, we're going to have twice as many of those values because our period is now happening twice as fast. 4 times 2, 8. There we go. Okay, so it makes sense why we have 8 answers right here. Okay, our next example, there's a little bit of a typo here, a little bit of formatting issue. The bottom equation goes for this example 6. So right here, we're just finding all real solutions for this equation. Okay, so we're going to start off by factoring out a cosine. That's going to leave us with 2 sine minus 1. Now we can apply the zero product property, set each one of these equal to 0, and we're basically just solving 2 separate equations by themselves. Okay, this second one here, I just added 1 and divided by 2. That's how I got sine of x equal to 1/2. So on my unit circle, where's cosine equal to 0? At pi halves. And then it's going to repeat itself every pi because the cosine value is 0 at pi halves, 3 pi halves, 5 pi halves, 7 pi halves, basically every vertical axis. So I'm going to say plus pi k. And where is sine of x equal to 1/2? Well, it is equal to 1/2 at pi 6, and then it repeats every 2 pi, so I'm going to add 2 pi k, and it is equal to 1/2 at 5 pi 6 plus 2 pi k. It's going to repeat that value every 2 pi. Our next example is a quadratic. So I'm going to check real quick to see if it factors. I believe it does factor. And it factors into 3 cosine of x minus 2 times cosine of x plus 1. Zero product property, this thing. And we get where is cosine of x equal to 2/3, and where is cosine of x equal to negative 1. Well, we can do this one really quick. Cosine of x is equal to pi every 2 pi k. Well, cosine of x is equal to negative 1 at pi and every 2 pi k. Super simple there. Okay, but this 2/3 is not a ratio on our unit circle that we're immediately familiar with, so we're going to have to use inverse. So we're going to have to take the arc cosine of 2/3. So if we take the arc cosine of 2/3, oh, sorry, I'm in radian mode right now. I'd like to be in degree mode. I'm going to do this example in degree. So arc cosine of 2/3, I'm going to get 48 degrees, of 48.2 degrees, and it's going to repeat every period. The period of a cosine graph in degrees is 360. Okay. Now cosine is also positive 2/3 in quadrant 4. Okay, so just drawing a little mini picture of that. Cosine is going to be positive right there at 48 degrees, and then it's going to have the same cosine value here at 48 degrees. So I'm going to take 360 minus that answer, and I'm going to get my second place where cosine is always going to be positive 2/3, and that is 311.8 degrees plus the period 360 degrees. Okay, so there's our other two answers. Our last one here looks a little bit froggy because it's got a cosine of 2x, got a sine squared, it's got a regular cosine of x. So I'm going to do some substituting based off of my 6-4 notes in that table there. Don't worry, you'll get that same table on your assessments. But I'm going to do some substituting to get everything in the same terms. And because this one is cosine of x, I would really like everything to be in cosine of x terms. So looking at my 6-4 notes, I'm going to recall that cosine of 2x is equal to 2 cosine squared x minus 1. Sine squared x is equal to 1 minus cosine squared. And I still got my minus 3 cosine of x is equal to 1. Okay, so my 1's are going to cancel off. And what I'm going to do is I'm going to add everything over to the right side so that this negative cosine squared becomes positive. So we got 0 equals cosine squared x minus 3 cosine of x minus 1. Okay, I'm sorry, I didn't add everything over to the right side. I moved everything over to the left side. Cosine, 2 cosine squared minus cosine squared is cosine squared. There's my negative 3 cosine, and then I just shifted that 1 over, so it became negative 1. Sorry for the confusion, but we notice we have a quadratic, and nothing multiplies to negative 1 and adds to negative 3, so this thing is going to require the quadratic formula. So let's go ahead and do it. Cosine of x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and we're going to end up, that's going to give us cosine of x is equal to 3 plus or minus radical 13 over 2. Okay, now when you go to plug this into your calculator, take the arc cosine of this, one of these is going to give you a negative value. One of these is not going to have a cosine, or it's going to give you a value bigger than 1 or less than negative 1, which is not going to allow you to take the arc cosine of it. Only one of these is going to work. So the plus or the minus will work. I think it's going to be the minus one that works, but let's go ahead and figure it out. So here we go. Arc cosine of 3 plus radical 13 divided by 2, close those parentheses, and that's where we get our error. Okay, it's a domain error. I have a feeling that 3 plus radical 13 over 2 is a little bit bigger than 1. It's impossible. So it's clear. And then let's go back and change that plus sign to a minus sign, and we see we get 107 degrees. 107.6 degrees. So that's going to repeat every period of cosine at 360 degrees. Okay. And that's a degree symbol right there. Okay. Our second answer, where cosine is going to be equal, whereas cosine is going to be this same value, 3 minus radical 13 over 2. It's going to be it's a negative one, clearly. Cosine is negative at 107 degrees. So we can draw a small little picture. We know that this is what we have. And that's true. And that is 107 degrees, 107.6 degrees. So we know that cosine also is going to have that same value, 3 minus radical 13 right here, at 107.6 degrees less than 360. So that's what I'm going to do on my calculator. 360 minus, oh, that's 306. 360 minus that number, and our second answer is 252.4 degrees repeated every 360 degrees. Thank you very much. You see your homework there at the bottom. I look forward to working with you in class.